Welcome everyone. In this video lecture we will study about Newton's second law. Okay, so in the first law, as we have learned, that the first law was telling us how does the object respond when there is no unbalanced force. Okay, and this is important. So first law was saying object at rest will remain at rest, object in motion remain in motion when there is no unbalanced force, right? In the second law will tell us what happens, okay, what happens when there is unbalanced force. So this is important. First law was telling us what happens in absence of it, and in the second law we will understand what happens when the unbalanced force is not equal to zero. Okay, so there are two definitions for Newton's second law. Both are same, it's just different way of saying it. In the one definition it is saying that the rate of change of momentum of an object is proportional to the unbalanced force. Okay, and the second definition is saying that acceleration of an object is produced by the net force is proportional to the magnitude of the force as and inversely proportional to the mass of the object. Okay, so both the definitions are same, and in a second we will understand both one in more detail. Let's look at the second definition in more detail, that's more easier. So it is telling us acceleration of an object. Let's say acceleration of an object is A, is produced by net force. So to make things easier, let's consider we have a box. We are applying some force A, okay, and the box has some acceleration A. So it is telling us, let's say acceleration and the force in the same direction. So acceleration of an object produced by the force is directly proportional to the magnitude of the force. Okay, direction is also same, and it is inversely proportional to the mass of an object. Let's say the mass of an object is m. So it is telling us the acceleration is proportional to the force and inversely proportional to the mass, and the direction of an object of acceleration is same as direction of force. Okay, so and this is basically the definition of acceleration. So if this box is on rest and we are applying some force, this box will start moving with some velocity, some acceleration, right? So that acceleration as produced from the force is equal to force upon mass, or you can also write as force is equal to mass into acceleration. Remember, force and the acceleration would be in the same direction. So if this is moving in the east, force would also be in the east. Okay, remember that. So force is equal to mass into acceleration, and direction of the force is same as direction of acceleration. Let's look at an example here. This person is trying to push the car. Let's say car is about 1000 kg. Person is applying some force. Let's say person is applying the force of 100 Newton. Okay, and then the direction of the force is this one. Let's say that is positive. Okay, this direction is positive, and the car is moving with acceleration A. Now we want to calculate acceleration A. So based on our previous, we know acceleration is equal to force upon mass. We know what is force is 100 Newton, mass is 1000 kg. So acceleration is 0.1 Newton per kg. Okay, we also know the unit of acceleration is 0.1 meter per second square, and the direction would be in the positive direction because we say this is positive. Okay, so I hope that makes things clear. Let's look at the second definition now. Second definition is telling us the rate of change of momentum of an object. So we know the momentum is from our previous lecture is p. So it is telling us the rate of change of momentum. So which is dp by dt. Sorry, this is dt, or you can say rate of change in p. Right? P is momentum here, is proportional to the applied unbalanced force. So let's say this box is moving with some momentum p. Now we are applying some force F. So the rate of change of momentum dp by is equal to F. Okay, we know what is momentum. Momentum is mass into velocity. So we can say dp by dt, mass into velocity, is equal to F. Okay, now we also know mass is not going to change. So mass, we can take mass out. dv by dt is equal to F. We know dv by dt is acceleration, right? Because rate of change of velocity is acceleration. So mass into acceleration is F, or A is equal to F by m. So and this is the same thing which we have learned before, right? So A is equal to F by m, and in the new one also we have looked A equal to F by m. Okay, so both definitions are same. One is saying that the rate of change of momentum of an object is proportional, this is important, proportional to the applied unbalanced force. Okay, that is the resultant force on the object. And second is saying the acceleration is proportional to the magnitude of the force, and direction would be same as force, and also inversely proportional to the mass. So it is telling the definition in the wording format. So it's pretty simple. I think the discussion we had will make things easier. Let's look at some examples here. It is asking us determine the acceleration when a 10 Newton force is applied to 1 kilogram object. So if I want to draw this out, let's say I have a 1 kilogram object and I'm applying a force F which is equal to 10 Newton. It is telling me calculate the acceleration. So for the first one, we know acceleration is F by m. Okay, and let's say this is a positive direction. Okay, so F is 10 Newton and m is 1 kilogram. So acceleration is going to be 10 Newton per kg, or you can say 10 meter per second square in the positive direction acceleration is. And the second question, it is asking us calculate the acceleration for a 100 kilogram object. So now the mass of the object has gone up, but the force is same. So let me use a different color here. So the mass is now 100 kg. Force is still 10 Newton. It is telling us to calculate acceleration. Again, acceleration is F by m. So which is equal to 10 Newton by 100 kg now. So which is equal to 0.1 Newton per kg, or you can say 0.1 meter per second square. Okay, so I want you to remember, like for a small less mass object the acceleration was 10, now it is 0.1. So if even though you're applying the same force, based on the definition we know acceleration is dependent upon the mass. So more mass an object has, the less acceleration it would have for the same force.